IPTV is Internet Protocol Television. It is a bandwidth hog service. Frequently used transport schemes for IPTV include unicast, broadcast, and multicast. Multicast transport scheme has been proven to be the most bandwidth efficient technology. It has been shown that soft frequency reuse can achieve a better spectrum efficiency relative to the integer frequency reuse and the fractional frequency reuse. In soft frequency reuse, the overall frequency band is divided into 3 bands of equal size A, B, and C. Cell edge users of adjacent cells must use different frequency bands A, B, or C. However, cell center users can use all frequency bands. The base station transmits signals to cell center users with a smaller power level P0, while to cell edge users with a larger power level P1. Mobile IPTV services have been becoming popular. However, such services are bandwidth hog applications relative to voice services. Therefore, the questions arise. First, how to offer mobile IPTV with better performance while preserving qualities of voice services. Second, how to increase the spectrum efficiency and reduce inter-cell interference among neighboring cells. The design goal of our spectrum allocation algorithms is to maximize the number of admitted IPTV users while preserving the QoS of conventional voice services. Our proposed solution is as follows. First, use soft frequency reuse and multicast IPTV schemes. Second, assign a higher allocation priority for voice services. Third, adopt dynamic algorithm to coordinate the spectrum allocation among cell edge bands of neighboring cells. The proposed static spectrum allocation algorithm is designed to be used under the condition of symmetric load among cells. A voice request from a cell center user can be rejected only when the overall bandwidth is completely depleted by voice services. A voice request from a cell edge user can be rejected only when the cell edge bandwidth is depleted by voice services. However, the TV channel with the least number of users may be dropped if no bandwidth is available for a new voice service request. An IPTV channel request from a cell center user can be rejected only when the requested channel is not multicasted and no bandwidth is available. An IPTV channel request from a cell edge user will be rejected if the requested channel is not multicasted and no cell edge bandwidth is available, or the requested channel is multicasted using cell center band and no cell edge bandwidth is available. To further increase the spectrum efficiency under the scenario of asymmetrical loads among adjacent cells, the cell with a heavier load, for example the cell marked in red in the slide, can borrow the frequency band from its neighboring cells with lighter loads. The blocking rate of voice and IPTV services under the static allocation algorithm were compared using simulations. The results show that the soft frequency reuse achieves the best blocking rate performance. To demonstrate the performance of dynamic spectrum allocation algorithms, another 2 simulation scenarios A and B were considered. The cells marked in red have the heaviest load, while the green ones have the lightest load. This slide shows the blocking and dropping rate performance of cell edge users. It demonstrates that the dynamic allocation algorithm significantly improves the blocking and dropping rate performance of cell edge users. The dynamic algorithm improves not only the service quality of cell edge users but also that of all users in the whole cell. This slide shows the blocking and dropping rate of all services in a whole cell under simulation scenarios A and B. The blocking and dropping rate of dynamic SFR reduces for the cells with heavy and medium loads, while it is preserved for the cells with light loads. To conclude, in this paper, multicast scheme and soft frequency reuse is used to enhance spectrum efficiency and mitigate inter-cell interference. The proposed spectrum allocation algorithms can achieve the best blocking and dropping rate performance. Finally, dynamic spectrum allocation algorithm outperforms the static one.